In this lesson, I'm going to demonstrate how to graph horizontal and vertical lines from equations. The learning target states, I can graph horizontal and vertical lines. The language target says, I know I can do this when, given a linear equation I, identify whether the equation represents a horizontal or vertical line, plot the appropriate intercept on the coordinate plane, and then draw a flat line in the appropriate directions and draw arrows on the ends of the line. Let's talk a little bit about what horizontal and vertical lines might look like. Looking at the figure on the left, you'll notice a horizontal line. It's horizontal because it goes from left to right. But what's interesting is that the equation for a flat or left to right or horizontal line is actually y equals a number. We usually think of x as our left to right or a horizontal axis, but with vertical and horizontal lines, the equations may be opposite of what you would think. So the graph of y equals b is actually a flat line from left to right. Keep in mind that b would generally be replaced with a number. You can also note, looking at the diagram at the left, that they wrote the y-intercept for us as 0, b. Now, look at the figure on the left for the vertical line. It's going straight up and down, which is how I know it's vertical. And in the notes here, we will write that the graph of x equal to a, where a is a number, is a vertical line, meaning it goes from bottom to top. Let's get some practice graphing these equations. The instructions tell us to graph each linear equation. One hint that it may be a horizontal or vertical line is that looking at the equation, we do not have both an input and an output. We do not have both a y and an x. We simply have one of the variables in the equation, and in this case it's y. I can either look back in the notes and remind myself what a line that says y equals looks like, or I can think about it this way. If I'm looking at my coordinate plane, where does y equal to? Well, one place where y equals to is obviously here, on the y-axis. But I can also note that y is equal to 2 here, and 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 so on and so forth. And in fact, we will find that there are literally an infinite number of points that could exist there at y equals -2. So I draw a flat line, horizontal from left to right, with arrows on the ends. Take a look at the next problem. It asks us to graph y is equal to 4. Once again, I look at the coordinate plane and ask myself, where could y possibly equal 4? Well, probably there. Then I ask myself, where else could y equal 4? Well, any points along this continuous line. So I'm going to draw a line through that point and add arrows on the ends. Take a look at the next problem. Y is equal to 1. Once again, looking at the coordinate plane, I find where y equals 1 and make a point. But I could also note that y equals 1 here, 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 all the way to infinity in both directions. Therefore, I can graph this equation by connecting those points to form a line and adding arrows on both ends.